Okay, right. So this is the first quadrant, just to remind you. Right, but you're not supposed to sleep in class. Okay. All right. So this is the first quadrant. In the first quadrant, the angle theta, okay, angle theta itself, if it's acute, it will be equivalent to 360 degrees plus theta. So if I give you an angle like, let me write it here. Let's say if I give you an angle like 400, okay, 400 minus 360 degrees will give you what? 40 degrees. So in the first quadrant there, what those formulae are saying is, if you've got an angle like say sine 400, the ratio of sine 400 is equivalent to sine 40. You can verify that with your calculator too. Okay? Because 400 degrees is in the first quadrant.
So it's not
Okay? Sine 400 is equivalent to sine 40. Okay. I hope you are aware in the time that if I start from the x-axis in an anti-clockwise direction, like this, it will be 90 degrees, then 180, 270, 360. If the angle is 400, means I have to move another 40 degrees. And I'll end up stopping inside the first quadrant. Okay, so 360 from 400, you get 40. So the sine of 400 is the same as the sine of 40 degrees. The cosine of 400 is the same as the cosine of 40 degrees. You can check that with your calculator.
Yeah, it's right.
Tan 400 is equivalent to tan 40. Okay? That's what these formulae are saying. Okay? All three. And as you can see, the ratios are positive. There is no minus 1 as a coefficient. So that's the first quadrant. It's in line with the cast diagram that you were taught last year. In the first quadrant, all three ratios, sine, cosine, tan, are positive. Yes. Put sine 40 and memorize the answer. And then sine 400.
So what the equation?
Well, so don't worry, we are going to get to the questions. No, it's not a negative. Okay. Here, the idea behind the reduction formula is to write any trigonometric ratio which is more than 90 using an angle which is greater than 90. So, this 400 here, in this 400 there is a 360. Agree with me that? Because 360 is one revolution. So if I start from this point here, going in an unclockwise direction back to this point, that's 360 degrees. But if my angle is 400, means I need another 40 degrees up, which will be the first quadrant. So what that means is both 440 degrees are at the same point in the first quadrant. Right? What is your calculator? Put this in your calculator. Sine 400, memorize the answer, and sine 40 degrees. And I showed you how to get this 40. You subtract 360 degrees from 400 and you get 40. These two are the same, they'll give you the same answer. Sine 400 is equivalent to sine 40. So, I hope that your calculator, okay, all right, can I have your attention? Can I have your attention? Your calculator must be in degrees. On the screen, there must be a D. We are in trigonometry now. If you check your calculator on the screen, there must be a D. If there is no D there, if there is a G, they have to convert the G to a D.
Wait, so what is it?
Then you put sign 40. Okay, wait. I say, what are reduction formulae? You understand what they are? They are a group of formulae that are used to write trigonometric ratios, sine, cos, and tan of angles that are more than 90 degrees using an angle which is less than 90. So we are saying any trigonometric ratio of an angle which is more than 90 degrees can be written using an angle which is between 0 and 90. So if I give you, say, 200, for example, right? 200. 200 is in the what? Third quadrant. I hope you know you are familiar with your cast diagram. All of you. 200 degrees is in which quadrant? Third. So in the third quadrant, our reference is 180 degrees. So 200 can be written as 180 degrees plus 20 degrees.
Why not just write it as 200?
Because we want to rewrite a reflex angle like 200 using an acute angle like 20 degrees.
I'm getting reduction. So theta has to be like less than 90.
Yes, theta is acute. I even underline it here. Theta is acute. I hope you all understand what acute means. Acute means the angle is between 0 and 90 degrees. That's what acute means. So we can write the trigonometric ratio of any angle more than 90 using an angle which is less than 90 but greater than 0 degrees. I said it. Okay? Well, if you're not getting it for now, when I start doing examples, maybe you will. So that's the first quadrant. The second quadrant, if we have got an angle like, say, 150 degrees, our reference we use 180. So which angle can we subtract from 180 to get 150? 30. Which means 150 can be written as 180 degrees minus 30 degrees. Okay? What that means is, if I give you, say, sine 150, you can write sine 150 using 30 degrees as sine 30 degrees. Because in the second quadrant, sine is positive. Remember, sine is what? Positive. From your cast diagram. That's why I did the revision yesterday. That's why I was going over the cast diagram yesterday. So you should have gone home and refreshed yourself so that you can be ready for the grade 11 part. Yes. Yes. Then negative disappears because 150 is the same as 180 minus 30 degrees. Generally here we use positive angles. For now we are dealing with positive angles. I will talk about negative angles later. So this theta here, it's a positive what? Angle. The third quadrant and the second, our reference is 180. If the angle is between 90 and 180, we use 180 degrees as our reference. If it's between 270 and 180, we use 180 as our reference. If the angle is between 270 and 360, we use 360 as the reference. Like say if I give you an angle like 330, we which angle can you subtract from 330 to get, sorry, from 36 to get 330? 30 degrees. And 30 degrees is acute. Okay? So, that 330 can be written as 360 degrees minus 30. This 30 here is like that theta. So, the same theta that's here, that's the same theta here. So, what that means is sine 330 is equivalent to sine minus sine 30, because in the fourth quadrant, sine is negative, so we have to put this minus in. Don't forget your cast diagram. Your cast diagram is now more important than last year. That's why I didn't rush to get into grade 11 work straight away. I had to refresh you a little bit because it's been a while since you did grade 10 too.
So how many kilometers?
Okay, for now we'll do this 12. We'll add more. Okay? So you need to be familiar with this. Next year, when you're in grade 12, when you do another group of formulae, this will become much easier to understand. But for now, you have to memorize. Okay? And your quadrants are very important. That is, your cast diagram is very important. Okay? So let's do a bit of some application. Okay? Let's do a bit of some application. I don't want to rush to introduce this group here. We'll talk about like what you can do is, let me stop the lesson here. Right? You go home, memorize this. Right? When you come back on Monday, you start applying this, then I introduce another group.